Well, hi. I decided that I'm getting enough interest in the videos for Crash Course that I'll continue posing some problems. I need some catching up to be done because I was gone all summer. And but I'm not going to do the answers. So I guess you could put the answers in the comments and we'll just discuss it like that. I guess if the interest picks up a lot, I might have some time to go back and do some answers, but at this point, it's way not worth it for me. I also decided to change the format a little bit. I'll put the questions right here and my face right there so that you can see the progress of this zit right here. I am 36 years old and here we are. So the first question right here is about pressure at depth. And so there's a reason that those IV bags are always up on stands. And you know, I'm giving you weird units too, grams per cubic centimeter. You'll just have to deal with that. The next question is about the Titanic. What's it say here? Oh yeah, okay, so I'm giving you the ocean water density, and that's not super saturated salt water. Okay, so obviously ocean water is salt water, but when we say salt water, sometimes we mean super saturated salt water, which has way more salt in it. So this particular pressure is given here as, wow, that's really, really deep. So I guess the question is, how deep is it? And there are easy ways to do this, and you get some really neat observations. I hope you find an observation about how deep you have to go to get 1 atmosphere of increased pressure. That leads you to a lot of interesting discussions about the bends and Radiohead and such. The other question is, I'm asking what happens to the buoyant force if you go down and grab an artifact from the Titanic and bring it up. The third question is about 2 identical glass cups, probably on a boat also. You fill one of them with water and place 2 ice cubes in the other and then fill it with water. So this is important because the amount of water, the amount of liquid water in the 2 cups is not the same. So do you understand that? Maybe you could draw yourself a little picture. As the ice melts though, will the cup overflow? So you understand that both of the cups are just on the edge of overflowing when we begin this discussion. Question is the one with the ice cubes in it going to overflow eventually or never? Next question, question 4, is about the water that you need to make this enormous battleship float. This was one of the first ironclad actually famous in Missouri. The Monitor fought in the Mississippi River. Go figure. So I guess I'm gonna let you design the container to float the boat in whatever way floats your boat, and I'm gonna ask you to explain how much water we need to support the Monitor. It's a very, very big thing. Let's see, that is almost a gigagram. Wow. Question 5 is about floating ice. The question is about, well, what fraction of this ice cube is below water? And you can look up the density of ice and the density of water and do the calculation. It's about a 10% change. So maybe that, if you don't feel like looking it up, then just go with that. So I'm asking about, again, kind of Titanic related stuff, but not ocean water. Let's just leave it be fresh water. And I'm just asking for the fraction of the bulk of the dang thing that lies below the water. Turns out that'll be the same as the fraction of the height that's below water if it's a cube, because we'll have a nice assumed constant cross section. And you've seen this all the time. You see ice cubes, you know exactly where they float, what percentage is below water. Anyway, put that together. The 6th and final problem for the chapter is a bonus problem. It's very challenging. There's this hollow steel ball, and the walls are exactly thick enough that it floats neutrally buoyantly, which means you can place it at any depth in the water and it will just stay there, like a fish, I guess. You know, fish control this with swim bladders, which is pretty cool. And if they get too much air in their swim bladder, they sit up at the top of the fish tank and eventually die. So maybe that's not very funny. but I guess I'm trying to ask you what the thickness of the ball is. And when I did this problem the first time, I got caught up on the fact that it's giving us diameter. Be very careful, that is not radius. You see the problem as I see it. Good luck and good night.